Assalamualaikum and welcome to our video. The purpose of this video is to present a final year project entitled Produce a Prototype of Neutral Film Technique Board Using a 3D Printer. Let us introduce ourselves. My name is Zulaikha binti ZULKEFLY and my metric number is 90DTP 90F1019. And my partner is HANIS HAKIMAH binti PAUDZI and her metric is 90DTP 90F1018. And we are under the supervisor of Encik Muhammad bin Saleh.
The neutral film technique NFT hydroponic system is a planting method for plant where plant roots absorb fertilizer from a shallow layer of water. The problem that is always faced by user of NFT hydroponic system is the design of the net pot, which is a less efficient market in terms of fertilizer absorption and roots growth. The objective of this study was to produce a new net pot design supported by a root reservoir using 3D printer technology. This study was carried out by observation and performed a comparison of root growth between the common ordinary net pot with the new design net pot. The findings of the study found that custom leaf plant in a new design net pot show a good rate of root germination compared to custom leaf plant in a ordinary net pot. A prototype of this new design net pot as well can be produced on a large scale by using the resin casting method as the final product to directly to the consumer. In conclusion, the new design net pot prototype design show a positive impact on NFT hydroponic cultivation technique.
From reading and research, there are two problem statements for this study. According to Michael, net pot are an important part of hydroponic system. Net pot help provide support to the plant. Aside from the various measurements, there are some qualities and ease of use that are not the same. The wrong selection of net pot will interfere with good root germination. This problem has a negative impact on crops that use this system because they do not get good basic necessities. The possible cause of this problem is the size of the net pot used. The next problem is the poor quality of the net pot. There are many quality net pot available in market. Improper selection of net pot will cause net pot to rot easily before the planting period is over. The cause of this problem is because the net pot will always be moist throughout the planting period. Perhaps the study conducted by Sulaiman can help improve the problem.
In this study, there are three objectives of the study, which is to study various nutrient film technique NFT pot using in the market, to design root carriers suitable with nutrient film technique NFT, and lastly, to develop nutrient film technique NFT pot prototype using a 3D printer.
The scope of this study are apply rapid prototyping technology in the manufacture of nutrient film technique NFT net pot. Plants that can be used in the NFT system are plants that are fibrous and soft roots such as pak choy, coriander and kesum. Producing the product up to the prototype level only. Net pot and pot are used in round pipe with a diameter of 4 inches.
There are three methods in the methodology used based on the objective of the study that has been made. Among them are research, design, and develop. We have done research on rapid prototyping, NFT, fertilizer, type of filament, and CAD apps. For the design, we have designed our new net pot using Inventor software. This is a picture of a 3D design that has been made. And lastly, we use a 3D printer to create a prototype from the inventor's new net pot design results. To produce a prototype using a 3D printer, there are several steps that need to be done, namely Creation. We use 3D modeling software like Inventor to create our own design. Create a three-dimensional blueprint of the digital file of the object to be printed. Second, STL. The next step is the CAD model file needs to be converted to an STL file to tessellate the 3D shape and slice it into digital layers. The complete design is converted to STL to generate G-code. Slicing. The STL file is then transferred to the printer using custom machine software. We use Ultimate Cura 4.11.0 for the slicing process on a 3D printer. Slicing process is to slicing divider or cut a 3D model into 100 or 1000 layers, telling the machine what to do step by step. Lastly, printing. 3D printer will start to produce the prototype. The 3D printer builds the bottom layer first, after which it will build the next top layer.
The level of water pumped into the system is 1/4 of a pipe. The level of water in the pump depends on the flow rate of the pump. When the pump is stopped, then the level of water flowing in the pipe will decrease. The remaining water in the pipe when the pump is stopped is approximately 25 mm. The remaining water found the pipe is a source of fertilizer nutrient. The new design netpot base touches the base of 4-inch diameter pipe, while the ordinary netpot is 1/4 of a 4-inch diameter pipe. New design netpot still receives nutrient even though the water flowing in the pipe is less compared to ordinary netpot which receive less nutrient. Ordinary netpot need to use absorption media such as fat cloth to absorb nutrient, while new design netpot does not require absorption media to absorb nutrient.
The way to prove a design is made effective is by means of data collection. Data were collected using 3 different types of tree, namely kesum, coriander, and pak choy. Data of kesum trees on ordinary netpots have died, while the existing kesum tree on new design netpot are growing well. In terms of kesum tree roots, the roots on ordinary netpot did not germinate well, while the roots on new design netpot germinate long. For pak choy data shows the growth of pak choy tree on new design netpot is larger and the number of leaves is more than pak choy tree on ordinary netpot. The root of the pak choy tree on the new design netpot is longer than the ordinary netpot. There are several suggestions are presented to future researchers, especially the improvement of netpot and pot in order to be an improvement in the hydroponic cropping system. First, suggested by the researcher is to improve the design on the netpot. Redesign the netpot by narrowing the space between the holes. It is suggested that other researchers could use smaller planting media such as cocoa peat. Thus, when a small hole space is designed, then the researcher can use various other types of plant media and the plant media will not come out of the netpot. Improve the design of the pot. Redesign pot by improving on the curve on the pot. This is so that the researcher can use his pot on a 3-inch diameter pipe. Thus, the researcher has the option to use a type of system that use either 3-inch or 4-inch pipes. Use solar system for support system. Usually, the support system use electrical energy to pump water. When solar systems are used, then electricity can be reduced. Indirectly, researcher can reduce the cost of electricity. Make mass production by patterning the design of netpot and pot to be molded. After that, the researcher can make a resin casting. This can save production costs to make netpot and pot. This is because the prototype made requires high cost. Lastly, convert a pipe of size 15 mm to 40 mm. When the researcher uses a 40 mm part, the researcher does not need to use a flow rate regulator to regulate the amount of water entering the system.
Based on the observation and research result obtained, researcher can prove that the new design net pot is better than the ordinary net pot. This is evident by the collection of data through a comparison between the ordinary net pot and the new design net pot. This study was carried out using a support system that is NFT kit. In this study, the effectiveness of design net pot is evident by good tree germination and root germination on the new net pot compared to root germination and tree germination on the ordinary net pot. In the assessment made, overall the new design net pot is more effective and meet the design characteristic of the hydroponic system. The production of a new design net pot can solve the problem that arise and be able to answer the objective of the study, especially for researchers and the users of hydroponic system. The researcher hope that this project will be able to help users of hydroponic system to solve net pot problem faced by users and researchers of hydroponic system. Therefore, overall, this study has been successful and achieved the objective of the study that was set at the beginning of this study. Finally, this new design net pot can give high impact in the hydroponic system.